Hey there, Aditya Kamak here. Welcome to your favorite channel, AdiAdvik Tutorials. Today we are going to discuss about simple pendulum, and this is the part 4 of the series, the measurement and experimentation, class 9 ICSE. Simple pendulum has a bob which is round in shape and it has a string. It looks something like a swing. You may have played swing in your childhood. It is just like that, but there are a few differences which we are going to talk today. There are many terms like amplitude, frequency and many more like that, and we are going to discuss it today. Before that, if you didn't see the part 1 which is of introduction to measurements and experimentation, you can click on this card right here. If you didn't see the part 2 which is about vernier calipers, then you can again click on this white thing, and if you are on your mobile device, then it will be black in color. You can go watch it. And if you didn't see the part 3 which is about screw gauge, then you can watch it by clicking there again. To discuss about simple pendulum, I will take a simulator. Let's dig into it. Welcome to my screen here. I have a simple pendulum simulation. The simple pendulum consists of a string which doesn't have mass and a bob which is here rectangular. It should be in spherical in real life, but this is a simulator, that's why they have given a rectangular bob. The length of the string is 0.70 meters. Let's check it with the ruler. Now at the point, and it is 64. Then how did it become 0.70? Can you answer? I will keep the ruler there. I shall reveal the answer now. The answer is 0.70 meters because the length of the string should be counted up to the center of the bob, which is this black line. Black line is matching with 70. That's why it is 70 centimeters, because it is in centimeter scale, which is 0.7 meters. The mass is 1 kg. I can change the mass, and I can also change the length of the string. Gravity and friction also can be changed here, but I'm not going to do it. Today we are going to learn all about the basics of the pendulum, all the key terms, and as I said, what is the relation between a swing and a pendulum, and why have we named simple pendulum, and many things like that. Now let's start. Here I have a pendulum. Now I can keep it anywhere, and if I play it, it will swing. Let's talk about all the key terms. These also are used in sound, because sound too is a vibration as this. Okay, you can see 40. And how did we get that number? It is the angle between this one blue line, dotted line, and where the pendulum is now. This angle right here. Why? It is because this angle is 0 degree. 0 degree angle. This is the mean position, and we take the angle between the mean position and the angle here. Mean position and the position now. That is the amplitude. Between this angle is the amplitude, as you can see. Amplitude is something that if you place it here, it moves this side and this side. Both the sides it moves 40. If the amplitude is 40, it goes to minus 40 and comes to 40. Minus 40, 40. Let's play it. Minus 40, 40. Minus 40, 40. Simple, right? Now let's discuss about frequency and time period. These both are dependent on time. Frequency is the number of oscillation. What do you mean by oscillation in the first case? Let's take an example. Here you have 40 degrees from here to here to here. Then the displacement will be 0 because it will be in the same position. Here and here again. Let's check it. Let me place it to here. One oscillation completed. Like that it does many oscillations. And on this basis we take time period and frequency. These both are dependent on time and the oscillations. And these both are like opposite brothers. One is good, one is devil. Time period is devil, frequency is good, or you can take either way. They both are opposite. If frequency is tall, then time period is short, like that. Any examples? They both are opposites of each other. Frequency, if frequency increases, time period decreases. If time period increases, frequency decreases. These both are like opposites. If one increases, other decreases, like that. And why is it so? We are going to discuss it now. Frequency is the number of oscillations in 1 second. Like let's take an example. Start. It completed only one oscillation in this much time. In 1 second, one oscillation. That's why the frequency is 1. Now what is the time period? Time period is like the opposite, as I said. Time period is time taken to complete one oscillation. Let's start. If you see it, it will become 1. Start now. 1. See, it is same. The frequency and time period here are the same. It is because it takes only 1 second to complete one oscillation. And you know, in 1 second one oscillation is frequency. And how much time taken to complete one oscillation is the time period. That's why both should be equal here. But they are different in number of oscillations. In one oscillation they may be same. But if you take 2, 3 or 4 oscillations, they are very different. For that now let's note down. Let's try an activity. Let's measure the time period and frequency for 10 oscillations. Start. 1, 2, 3, 4, 5. Enough. Let's do it for 5 oscillations, okay? For 5 oscillations, the time is 8 seconds. Then in 1 second, how much does it take? Same amplitude. 1 second. How many oscillations does it take? Start. 1 oscillation. 1 oscillation, right? For 1 second, it takes 1 oscillation. Here the frequency is like, it is dependent on seconds, like you should see the timer here in frequency, and in time period you should see the oscillations. And that is why it is inversely proportional. But there is a relation between these. Frequency is 1 by time period and time period is 1 by frequency. And that's why we take it inversely proportional. And now let's discuss about amplitude changes the time period and frequency or not? Let's check it. Only 3 oscillations, so that it becomes easy for us. 1, 2, 3. 5 seconds. It took 5 seconds for 3 oscillations. Now let's change the amplitude to 80 degrees and start it. Let's reset it and start. 1, 2, 3. 5 seconds. How didn't it change? How fast this more amplitude was moving, right? Big angle. Why it didn't do this is because when you have small amplitude, it should cover a short distance, but it doesn't have potential energy, so it moves slowly. When you have a big amplitude, it has potential energy. When you leave it, it goes very fast, but a long distance. That's why it is the same. Amplitude doesn't change the time period nor the frequency. Here I have 2 pendulums, one of a shorter length and one of the same length. Let's check. Now let's play this. This red pendulum is moving fast. It is faster than that blue one. Red pendulum is very fast, as you can see. We don't need stopwatch for that. You saw that length does matter. More the length, more the time period, less the frequency. Does more mass affect the time period and frequency? Let's check. Start. 1, 2, 3. 5 seconds. And now again 40. And let's reset it. Start. 1, 2, 3. It's the same time, right? 5 seconds. This doesn't affect the time period or the frequency, as you can see here, because the time is equal, 5 seconds and 5 seconds. Mass doesn't affect. Then let's keep the mass normal. And that's it. Now let's discuss about the pendulum's uses. It is used in clocks and in earthquakes. What? Yeah. Some buildings use pendulum, big pendulums in them so that the earthquake is driven away. Pendulum helps in driving earthquakes. Wanna know how? I'm not going to disclose it. This is the question of the day for you. And now let's discuss the differences between the swing and the pendulum. Pendulum, as you can see, moves that side, this side. It is as the swing, same as the swing. But the difference is, it is moving continuous. It has continuous force here, like a continuous force is applied to it. And in swing, nobody applies continuous force, right? And it doesn't move continuously. Like pendulum moves same, like this, same 30 degree that side, 30 degree this side. But in swings, if somebody pushes like this 63 degree, it may go to 90 degree or it may go to 30 degree. It depends on how strong or how slow a person pushes. Now let's go back to the studio. That's it for today. Now let's revise what we have learned. We have learned that pendulum has amplitude, frequency, the length you can measure, and many things like that, time period, and frequency is equal to 1 by time period is equal to 1 by frequency. We have learned that the length matters in change in time period and change in frequency. Amplitude is the angle between the mean position and the position which it is in now. Amplitude doesn't matter in the change in time period or in frequency either. That's it for now. Like this video only if you like it. Subscribe to this channel so that you don't miss out any educational videos in maths, physics, chemistry, bio. In short, mathematics and science. Share this video so that your friends can know more about this topic, the simple pendulum. You have learned more. Let your friends know more. That's it. Bye for now. See you later.